Okay, hi there. I'm going to answer this question for you. Um, so I'm assuming this looks like a grade 11 university question. That's what it looks like to me. So maybe that's what you're in. So look, you have this function, y equals x squared. So you're going to think about this as the parent function, right? So that's the parent function. And now you have one set of coordinates that's on this parent function, right? So the set of coordinates is 2, 4, right? And they want to know, write the new point. So in other words, when you do transformations, right? And these things here, let's see what they have. We have 1, 2, 3 transformations that are being applied to this this graph here, right? So what transformations do is that they will make your graph move and things like that, right? So right now, and I'm going to draw this very, very poorly because I'm using a tablet, but okay. So this is your, right? Y equals x squared looks like this. That's your parent function. So to this, there's been 3 transformations that are applied. You should know that these 2 are shifts, right? So these 2 here are shifts. That's a shift up. That's a shift to the right, right? So these are things that you hopefully know. That's hard to read. And then this one here is a compression because it's being multiplied by a half. And it's so really, I would say there's actually the 4 transformations. The 4th transformation is the negative here that actually flips the graph upside down, right? So roughly speaking, what this shape is going to look like this. So shifted to the right, shifted up. I'll do it in a different color, right? So it's shifted to the right, it's shifted up, and it's upside down, and it's going to be flatter. So roughly speaking, this is going to look like this, right? So this is your f of x. Your transformed f of x is equal to negative 1/2 x minus 2 squared plus 4. It's going to look something like this. So what this question is about is to say, okay, well, can you follow? For example, we know that the vertex here went from being at 0, 0, right? The vertex was at 0, 0. But on the new graph, your vertex is at 2, 4, right? So this is like your new vertex is at, right? It went right to and up 4, 2, 4, right? So what it's asking you, just like how this point here, the vertex on the parent function, corresponds to a specific point on the transformed graph, right? Well, you can follow every point on this graph. I could ask you, or you could be asked about any point, right? Just like you could follow the vertex, but you could follow any point. Why not follow what happened? Where does this point end up? The point 2, 4 on the black graph, right, your parent function, where does it end up after these transformations have been applied? It got shifted to the right 2 units. It got shifted up 4 units. It got reflected, right? It just like every other point. Now, in the end, here is the shortcut that hopefully you learned in your class, right? So this is another way of doing graphing, but it's called mapping, right? And it tells you, right? So remember that there's your transformations look like this. Y is equal to the number in front, we call it A, F at, well, right now you probably just have these 2. So I'm not going to confuse you with there is another one that shows up in here, but I'm not going to confuse you with that. I think we're calling it C in this course. And then, no, this is a D. This would be called D, and this would be plus C, okay? So here's how every single point, this is what happens to them, okay? The Y values are the easiest to follow because the Y values you just multiply by whatever your A value is, which in this case, the specific example that you have, is that A is negative 1/2. Your D value, the thing that gets subtracted inside the bracket, is 2, not negative 2 because it's minus 2. So minus what? It's minusing 2. And your C value in this case is 4. Okay? So the first 2, the A and the C, right? These 2 things affect the Y values, right? Because this is a shift up or down, so that affects the y values. This is a reflection in the x-axis, so it's an up and down reflection, and it's also a vertical compression. So whatever your y value is on your new graph, the red graph in our case, so I'll do it in red, this is going to be multiplied negative 1/2 by whatever the y value is. And then you're going to add, ran out of room, right? Then you're going to add 4, because that's my c value, okay? So negative 1/2 times y plus 4, okay? And then your x values now, well, here, the only thing that happens is this shift, right? So your x values, right, even though that shows a minus there, you saw that what that does, it's a shift to the right, which is actually increasing your x values. So this is another way of looking at things. Now, this makes it really easy if you have a specific point, like we do here, the point 24. Therefore, transformed in the new graph is going to look like this. I take my x value and I'm going to add 2. I'm going to take my y value and I'm going to multiply by negative 1/2. So that's going to be what? So 4 times negative 1/2 is negative 2. And then I'm going to add 4. So negative 2 plus 4 is 2. So therefore, the transformed, the corresponding point where 2, 4 ends up is going to be at the point 4, 2 on the new graph. So 4, 2 is going to look like somewhere around here. 4, 2 is where it ends up. So hopefully, wherever you're at in the course, you've covered this. This is mapping, right? And that's how you follow it through, okay? So hopefully that helps. Let me know if you need anything.